Thermodynamic scale of temperature. So this is a standard temperature scale adapted for scientific measurements of thermal properties and uses one fixed point, which is the triple point of water. So how does this go? Unlike thermometers nyingine zilizopita, tumeona lazima kuwe na upper fixed point na lower fixed point, but for this is a special type standard temperature scale ambayo inatumia only one fixed point ambayo ni triple point of water. So actually the major point of concern hapa is what is the triple point of water. So actually we know triple point of water is a phase or state whereby the three phases the water zinakuwa in equilibrium, which is the ice, which is the vapor, which is the liquid itself. Kwa zote zina coexist na zinakuwa in equilibrium. So that point ikifika inakuwa is the state what we call triple point of water. Na formula yake inakuwa in such a way kwamba if we want to know the temperature of a particular substance, we should have the pressure at that temperature ambayo tunapima, then divide by pressure at triple point of water. So the same thermometer, pressure yake itakayopima at temperature husika tunaopima, divide by pressure itakaosoma kwenye hiyo temperature scale at triple point of water. Kwa tuna multiply times 273 times 0.16, tunapata the answer in Kelvin. So the answer here inakuwa in Kelvin. So this is the standard temperature scale. So maybe you can ask yourselves, hii formula imetokea wapi? So we know principally thermometers zinazotumika katika kufanya thermodynamic scale of temperature ni constant volume thermometers, so that we measure the pressures as you can see. However, the mechanism is such that kama ilivyo kwenye constant volume thermometer, tunaiweka thermometer yetu katika kitu ambacho tunakipimia temperature, itasoma pressure. Then tunaweka thermometer yetu with the same volume ya gas, kumbuka ni constant volume thermometer. With the same volume ya gas tunaenda kuipima kwenye ikiwa kwenye triple point ya water. So that's what we do. So PT is actually the pressure of an ideal gas at a temperature T which is measured. And P at triple point is the pressure of the same volume of gas at triple point of water. So the concept is, kumbuka tunatumia ideal gas, inataka tutumie ideal gas, but in real sense we don't use ideal gas, tunatumia real gases. And we know real gases tukizipima at lower pressure, the more they are closer to zero, the more they behave kama ideal. So basically tunakuwa na errors, lakini in real sense inabidi tutumie ideal conditions which we don't have. So we know ideal gas equation, PV is equal to nRT. So katika pressure 1, pressure ya kwanza ambayo ni pressure at a temperature tunaipima, PT times volume is equal to nR temperature tunaoipima, okay, TT. Then at second conditions ambayo ni pressure at triple point with the same volume, nimesema of course the same number of moles because we are maintaining the volume somehow, the same number of moles, R and temperature at triple point. So if we divide the two equations, you can see the same volume ina cancel, nR zina cancel. So tunabaki na pressure at triple point, pressure at temperature being measured, na pressure at triple point divided by pressure at triple point. So pressure at temperature being measured divided by pressure at triple point ni sawasawa na temperature theta tunayoipima divided by temperature at triple point. So we know temperature at triple point is 273.16 Kelvin. So that is the reason why if you factor out theta, inakuwa theta ni sawasawa na pressure T divided by pressure at triple point times the temperature at triple point 273.16. So basically inakuwa hiyo. So our formula inakuwa governed by this. Is just simple. We shall see an example here. We have a particular constant volume gas thermometer which registers a pressure of 1.937 times 10 power 4 pascals at triple point of water, and that at boiling point of a liquid. So what is the boiling point of liquid according to this thermometer? So if you want to know the boiling point, we should know the pressure at boiling point divided by pressure at triple point times 273.16 Kelvin. So if we put in the numbers, pressure at boiling point ambayo ilikuwa ni hapa 2.16 2.1618 divide by 1.937, of course zote in 10 power negative 10 power 4 na 10 power 4, so they just cancel, times E273.16. The answer you should get here is 369.2 Kelvin. So that is the boiling point of the liquid according to this thermometer. So the temperature measurements described in that question were repeated using the same thermometer but with different quantity of the same gauge. The readings on this occasion ilikuwa ni 4.068 times 10 power 4 pascals at triple point na 5.503 times 10 power 4 pascals at the boiling point of the liquid. So A, what is the boiling point of the liquid according to this measurement? So according to this new measurement nitakuachia ufanye. So try putting the numbers here. You should get the answer is 369.5 369.5 Kelvin. That is the answer you should get. So try and see kama umenielewa, you should get that answer. And which of the two values is the better approximation of the ideal gas temperature and why? So we know hizi gas, ideal gas ni ile gas ambayo ipo kwenye ideal conditions ambazo they are non-existent, kwamba kwa mfano kama ni forces tunasema hamna friction, yani ni perfect conditions. But in real sense our thermometers tunatumia real gases. Now we know one characteristic ya real gases is that at very low pressures or at zero, okay, at zero pressure usually they behave kama ideal gas at zero pressure. So that means katika our two thermometers ambayo itatupa better approximation to ideal gas temperature ni ile ambayo ipo karibu zaidi na zero. So the lower the pressure, the more the real gas inaenda kwenye behavior ya ideal gas. So we can see kwamba hii second scenario na the first scenario zinatupa lower pressures, zimefanya measurements kwenye lower pressure. So this temperature is the one which gives us a better estimate of ideal gas. Yeah, 369.2 Kelvin is the one that is giving us a better approximation of ideal gas temperature. And the reason, as I've said, it is measured at lower pressure. So estimate the ideal gas temperature. We know from the previous question which of the two values inatupa a better approximation to the ideal gas temperature. Tumesema ni 369.2 Kelvin ambao ni values hizi za mwanzo. If we can see hapa tuna difference ya temperature ni 0.3 Kelvin. So tunaweza tukaitumia tukatafuta change in pressure ambayo inaifanya deviate from ideal, kwa sababu tumesema ina give a better approximation. So kwa kutumia hii change in temperature tunaweza tukapata change in pressure, then tukajua hata hii ambayo ina give a better approximation imedeviate kwa pressure kiasi gani, ili tupate the exact value ambayo itatupa ideal gas conditions. So we know that pressure 1 over T1 ni sawa na pressure 2 over T2. I think unakumbuka tulifanya hapa, tulionyesha hapa. We were deriving the same thing. Na by the way, hii ni Charles law ambayo inatuonyesha variation ya pressure na temperature. P1 over T1 sawa P2 over T2. So if we have pressure 1 which was the pressure ya ideal conditions ambayo zilipima boiling point hapa ambayo ni 2.618 times 10 power 4 divide by temperature yake ambayo ilikuwa inapima ni 369.2 Kelvin. Ni sawa na change in pressure over change in temperature ambayo ni 0.3 Kelvin. Change in pressure utakuja kupata ni 21.27. Okay, pascals. So if you take this one, because tumesema the more inarudi closer to zero, the more inakuwa ideal. So if this was the one that was giving us an estimate ideal condition, so inabidi tutoe this amount ili itupe a more close estimate ya ideal gas temperature. So tukichukua 2.618 minus 10 power 4 tunapata new pressure, tuseme pressure ambayo ina give estimate ya ideal ambayo inakuwa ni 2.616 times 10 power 4 pascals. So you can see the difference ni ndogo sana, ni kweli. Kumbuka hii sio times 10 power 4, hii ni 21.27 kama 21.27, haina power wala nini. So we will then use hii hapa kutafuta the ideal, ku estimate the ideal gas temperature. So again tutatumia ile P1 divide by temperature 1 is equal to P new au ideal divide by hiyo temperature ya ideal ambayo tuna estimate. So tunajua temperature ya ideal inakuwa ni sawa na P new times temperature 1 divide by P1. So we know P new ni 26.16 times 10 power 2.616 times 10 power 4 times temperature 1. Tulisema hapa temperature 1 ni 369.2 divide by pressure 1 which is 2.618 times 10 power 4. So you put in the numbers, unapata the estimate ideal gas temperature ni sawa na 368.9 Kelvin. Basi you are good to go.